video, you're going to be learning about how to solve equations where there are variables on both sides of the equal sign. So you're going to have a term with a variable on the left side as well as a term with a variable on the right side. What's really important for you to recognize is that the way that I solve the equation is one of four different ways that you could, at least four different ways that you could usually solve the equation. So if you don't like my way, what you have to understand is that there may be a way that works better for you. You may not want to move the term that I decide to move first. You may want to move a different term first, and that's fine. As long as you're creating additive inverses and zero pairs and you are combining like terms, you should be fine. And if your answer agrees with mine, then it means that your solution is as valid of a solution as mine is. The other thing that I want to ask all of you to do for this video is to write down the problems and the solutions. So you will be active learners again in this video. You will not just be sitting watching me solve, you will be writing down the equations and the solutions so that when you do have questions, we won't have to rewind the video and find the questions. You'll just be able to say, Miss Amita, I'm not really sure how to do this one. The last thing is there is a fraction equation, which is the very last example that I give. And really all it is making sure that you remember how to do fractions and equations. So that example you do not have to watch. It's the very last example. You do have to watch all of the other examples, which I think leads to about 7.5 minutes of video, but that very last fractions example you do not have to watch. So when you look at this equation, you should notice that there's variables on both sides. There's the 4x term on the left side of the equal sign and the 2x term on the right side of the equal sign. And as per your pre-assessments, this is something that most of us need to work on. So when we solve this equation, we are going to act as if we are moving all of the variables to one side of the equal sign and all of the numbers to the opposite side of the equal sign. So you are going to make sure that your variables are on one side together and your numbers are on the other side together. So there are four different ways to start this. I'm going to start this by moving the 2x to the 4x, and in order to do that, I'm going to do the additive inverse of 2x, which is negative 2x, and what I do to one side, I'm going to do to the other side. 2x and negative 2x create a zero pair, so I've eliminated the variable term from the right side. 4x minus 2x is 2x. I bring down the positive 8 and then equals 6. From here, this equation should be very familiar. This is a two-step equation. I'm going to move the positive 8 to the 6 by doing the additive inverse of positive 8, which is negative 8. That creates a zero pair, which means it's equals 0, so I don't have to put plus 0 because adding 0 to any number per the additive identity would equal that number. 6 minus 8 is negative 2. I divide both sides by 2, and I get x equals negative 1. I could put negative 1 back into the equation. 4 times negative 1 is negative 4. Negative 4 plus 8 should equal 2 times negative 1, which is negative 2, plus 6. Negative 4 plus 8 is 4, and 6 plus 2 is 4, sorry. And 4 equals 4, check, so I know that negative 1 is my right answer. This is the same equation, and I told you that you could solve this 4 different ways, so I'm going to show you another way that you could solve it. In the first way that I solved it, I moved the 2x to the 4x. I'm going to move the 4x to the 2x. When I do that, now I create a zero pair with 4x and negative 4x, so that variable term goes away. And I'm left with 8 on the left side and negative 2x plus 6 on the right side. I need to move the 6 to the 8 because they are like terms. And I create a zero pair with the 6 minus 6. 8 minus 6 is 2 equals negative 2x. When I divide by negative 2, I'm left with x equals negative 1, which is the same exact thing I was left with in the first way that I solved it. And it should be the same thing that you do with any way that you solve it. So here, again, 4 different ways for me to solve it. I'm going to go with moving the minus 2x. I don't like negative variables. It's a negative 2x, so I'm going to add 2x to both sides. I know I have to add because this is a minus, and the minus is attached to this 2x. Creates a zero pair. I'm left with positive 8 equals 8x minus 16. I add 16 to both sides. I'm left with 24 equals 8x. I divide both sides by 8, and I'm left with x equals 3. Remember, I can go ahead and check 3 and do 8 minus 6 should equal 18 minus 16. 8 minus 6 is 2. 18 minus 16 is 2. I win. X does equal 3. Left side has a variable and a number. The right side just has a variable. Actually, this type of problem is quite easy because it already tells you what term you have to move in order for you to have all the variables on one side and all the numbers on the other. If there's only a variable on the right side, that should be the variable side because there's already a variable term sitting on that side. Which means in order to get all the variable terms together, you are going to take the other variable term, in this case which is 4x, and do the opposite, which is minus 4x, to create a zero pair. Now you have your number alone on one side, and when you subtract, you're going to have your variable terms alone on the other side. At this point, you just divide by -2, and you're left with x equals -4. If you plug -4 in, 4 times -4 is -16. -16 plus 8 is -8. And 2 times -4 is also -8. So the left side does equal the right side. If you choose to move the 2x or the -8, you are going to create an equation where you've just moved something to a side where it's not going to help you solve the equation. The only first move in this case that's going to help you solve the equation in fewer steps is to move the variable that's on the side with the number to the variable that has nothing else on that side with it. So here is a challenger, right? Here's a problem where now you have a whole bunch of like terms on the left side and a bunch of like terms on the right side, and there's variables on both sides, and it's asking you to apply all of the skills that we've learned. So if you just focus on the left side, you're going to notice that you're going to have to distribute in order to be able to combine like terms. So when you distribute, you have to remember to put the 1, so it's -2x plus 8. I'm going to go ahead and continue by boxing and circling. I'm only focusing on the left side. And I'm left with 3x plus 8, which is a fully simplified binomial on the left side. I'm going to go to the right side, and I'm going to realize I'm going to box and circle just on the right side. -x plus 6, or -1x plus 6, that's your call. So now, after I've boxed and circled on the left side, and distributed on the left side, and I've boxed and circled on the right side, I'm left with an equation where there's variables on both sides. I'm going to add 1x to both sides. 4x plus 8 equals 6. I'm going to minus 8 from both sides. I'm going to be left with 4x equals -2. And when I divide both sides by 4, I'm going to be left with x equals -2/4, or -1/2. Okay, you could even decide that x equals -0.5 if you'd like. Please remember that equations very rarely end in whole numbers or integers, so it is best for you to get used to equations ending where x is going to be a number other than a whole number or an integer, and you can always check it by plugging the 1/2 back into the original equation. You can move whatever you want to the other side. I'm going to choose to move a 1/4x to its bigger fraction friend, a 1/2x. To move a quarter of the x, I'm going to do the opposite, the inverse operation. Positive 1/4 is -1/4. I'm going to do that on both sides. So this becomes a zero pair. I can cross it out. I'm left with 1/4 x. If this subtraction is confusing to you, okay, if that subtraction is confusing to you, take a paper and pencil, go over to the side and say 1/2 minus 1/4. Then I'm left with 3/4 equals, and I remember that the 1/8 has a negative sign, so I'm going to bring down the -1/8. Now, I know that a 1/4 x is a like term only with itself. It has no other friends in this equation. I'm going to leave it alone. I'm going to move the 3/4 to its friend, the -1/8. Let's cross out the zero pair. I'm left with 1/4 x equals. When I do this subtraction, I'm going to put the bigger fraction on top. I'm going to subtract the smaller fraction. The signs are different. I subtract, put the bigger number on top minus the smaller number. I have 6/8 minus 1/8, which gives me 5/8. I can from here, I can solve it two different ways, okay? I can either take this variable and say I'm multiplying by a quarter. The reciprocal of a quarter is 4 over 1. 4 over 1 times 1 over 4, they're multiplicative inverses of each other. If you multiply a number by its multiplicative inverse, you are always, always, always left with 1. Whatever I do to one side, I do to the other side. So on the left side, I'm left with x. On the right side, if I cross cancel, I'm left with 2.5. So x equals 2.5. If you don't like this and your brain doesn't work like that and you're saying to yourself, I have no idea how Miss Almeida is deciding to multiply by 4 over 1. This is what you can do. You can say to yourself, I know that this means the left side means a quarter times x. So the inverse operation of multiplying is dividing. From there, you can say to yourself, I also know that this is a complex fraction. And because it's a complex fraction, you can rewrite it as a nice, pretty, linear division problem. And a nice, pretty linear division problem of 5/8 divided by a quarter can be keep, change to multiplication, and flip. And when you keep, change, flip, it looks an awful lot like what I had done originally by just simply multiplying both sides by the reciprocal of the fraction that's the coefficient of x.